How are you, my students, and welcome to our today's class on exploratory data analysis. I am your facilitator for the day. My name is Miriam Kaloki from the School of Pure and Applied Sciences, the Department of Physical Mathematical Sciences. Welcome. So in our today's class, we have partly a theoretical introduction which will introduce us to our concepts of calculation. Now, in order to make sure that we can follow through, I would request you that you, 1, take your paper, 2, have your pen, and 3, don't forget your calculator so that we can be at pace with each other. Now, to begin us, we start with the introduction of our summary course outline. The first thing we want to look at is the definition of exploratory data analysis, followed by the basic concepts in statistics, followed by frequency distribution tables, followed by numerical summaries of data, which include measures of location, measures of dispersion, measures of shapes, and measures of relationships. And lastly, graphical data displays. So we start with the first outline, which is the definition. Of course, as per the name, exploratory, we are trying to explore our data. Now, to look at a more defined or more formal definition, then we say that exploratory data analysis refers to the critical process of performing initial investigations on data so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. Now take note, summary statistics and graphical representations is our key guidance into exploratory data analysis. What is statistics, though? We need to understand what statistics is, even as we start. First of all, it's a branch of mathematics. Secondly, it's actually a process. And what does the process entail? The process entails that you do data collection, you organize the data, you analyze the data, you interpret the data, and also present your results. Now, in statistics, we have concepts that we will look at, basic terms that we look at. First of all, we start with the population. Ideally, population refers to an entire pool from which a statistical sample is drawn. And we may refer to it as an entire group of objects, events, and so on. Whereas a sample, which most researchers use, ideally because of being able to access things like labor, money, and so on. For a sample, it refers to a small group of people or objects or items that are actually taken from this large population. Next, we have randomness. When we talk about data, to make it work best, randomness must apply. And what do we mean by randomness? It is the lack of pattern or predictability in events. Let me explain it simply. The idea of randomness makes us avoid what we call biasness, which is a key thing when it comes to statistics. We want our data to be good, then that means randomness must apply at all times. Then we have what we call independence. Independence is actually From a simple explanation, think of a coin. Every time you toss it, you have an outcome. We know that a coin has two sides, either the head or the tail. Now, if I flip it once, let's say I get the head. I flip it again, I get the tail. What has happened is my second result is not being hindered by the first result. Thus, we call that independence. Each of the events is independent. Now, of course, the one word that we keep using is data. But what do we mean by data? Data is actually, simply explained, facts or figures. Now, from time immemorial, data has been linked to computers. So every definition you look into will have a linkage to computer, but ideally data is just facts and figures or information that we want. In case you're doing a research paper, then you'll have to collect information for your research paper, which we call it data. Now, what are the sources of data? There are actually two main sources of data, starting with the primary data source and the secondary data source. The primary data source includes collecting information directly from your sample or from your population by either observation, surveys, interviews, focus groups, and so on. Secondary data, on the other end, is ideally data that is not first-hand. That is pre-existing data, which can be collected from articles, journals, the internet, and so on. Then we have data types. Data types have two large categories, that is qualitative and quantitative. To simply explain, qualitative refers to opinions, just that, opinions, those that you cannot place a value on. And a more formal definition, it actually is termed as categorical data. When it comes to quantitative, this is data that can be measured. It has values. Now with quantitative, it is further divided into two categories, either discrete data or continuous data. Now, to put it in a very simple way, discrete data is just countable data. The same way you can count people, you have 2 people, not 2.5 people. Then that becomes countable data, which is discrete. We have continuous data, still in quantitative, which gives us infinite possibilities. Now, such data let's talk of your weight. Your weight and your friend's weight will have a difference which has some decimals. What do I mean by this? When we talk of continuous data, it is data that lies within a range. So from 0 to 1, whereby 0 and 1 are the discrete values, the continuous one will be 0.1, 0.2, and so on, up to until you get to 1 itself. Now, how do we go about collecting this data? When we come to primary data, it requires that you can either have face-to-face interviews. These are very simple. You just need to book an appointment with whoever you want to interview if it's very formal. If you're doing a research study, of course, it means that you have to get permission, and also having identified the people that you want to get the data from, then you can go door to door getting the data that you want through interviews, face-to-face interviews. Now with technology, we have evolved. Nowadays we have telephone interviews, and most of them are on market research, whereby something that you've been using, the customer care will always follow up. How are you experiencing their product? We have online questionnaires. We have individual and group in-depth interviews. We have focus groups. Now for focus groups, I'll take the example of children in a preschool. These children, in order to get data from them, it's easier to have them together. Having them together means what? Once I present myself, I have questions to ask. If I approach just one child, it might be uneasy for them to give me the information that I want. But if I put them together, they will actually compete to answer my questions. So that defines focus groups. We also have observation. Now, we have seen this a lot. We have seen this a lot in terms of observation, where researchers go to new areas. They stay there for a very long period of time, just integrating to the normal life of that particular area in order to get information through observation. No questions asked, just them observing what is going on. When it comes to secondary data, the methods of collecting are actually published sources and unpublished sources. Of course, published sources will have more integrity, and in our case, we have a very strong institute that governs our published sources of data, which is the Kenya National Bureau of Statistics. So the first place that you need to think about when you want data, with regard to whatever, depending on the surveys that they do, whether it is the KDHS data, the economic survey, then they are for sure a good place to check out secondary data. So we come now to our next topic of interest, which introduces us to the calculations. Now, this is frequency distribution tables. Just from the understanding of the name, what does frequency mean? Frequency just tells us how often something happens. Then, of course, the table is able to show us when ordered well, how many times that thing happened. How do we go about to make frequency distribution tables? Now we have two that we are going to look at. One is when we have categorical variables, and the other one will be when we have numeric variables that require us to construct what we call a grouped frequency distribution table. So we start with our example for categorical. Now, I'll first read the example. We follow through with the results, but before we start calculating, we'll have to know the steps to follow in order to come up with what we want. Our example reads, let's say you survey a number of households to find out how many pets they own. So we have the results there, 3, 0, 1, 4, and so on. We want to construct a frequency distribution table that will make the data easier to understand. Now, what steps do we need to take in order to come up with that frequency distribution table? The steps are quite simple. First of all, we need to make the frequency distribution table. We will make columns, and the first column will be the number of pets in terms of categories. Then we tally them and count the tallies. If we go back to our example, if we critically look at our values, we can see 3, 0, 1, 4, 2. So it seems to us the highest value that we have is 0. That is those households that don't have a pet at all. We have 1. That is those households that only have one pet. then we have 2, 3, and 4, 4 being the maximum. So our categories are as the values, 0, 1, 2, 3, and 4. Okay? So we can proceed now to the real hands-on making of our frequency distribution table. So this is how we start it. We have said we are going to construct columns, and the first column is that we have to show our categories. We have already said that the category will be number of pets. So the first category, number of pets. Our categories are easy. We already saw we have 0, we have 1, we have 2, we have 3, and we have 4. Okay? So now, what is the next thing? The next thing is to tally. Now, a tally makes your work easier because you don't have to keep up with how many are this. No, no, no. You just need to go step by step, indicating each value that you come across in the data set as a tally until you're done. By the time I am adding all my tallies, then they should total to the number of my data set. Now, if we look at it, the first case was 3. So at 3, we tally 1. Okay? We're just doing strokes for our tallies. So 3. Next follows is 0. So we have a 0. Next is 1. We have a 1. Next is 4. Then 4. So 4, 4. We have 1. Okay? That increases the tally there. We have 2. Introduces us to 2. We have 0. Okay? We have 2 and 2. So 2 and 2. We have 0. Then we have 2. Then we have 0. Okay? Then we have 1. Okay? Then we have 3. So 3 has another score there. We have 1. Okay? Next is 2. Now 2, we already have 4 strokes. So to make it wholesome, the fifth one holds all of them together. So 2, then we have 1 and 1. So for my 1, we have 1, then 1. Okay? Then after that, we have another 3. Good. So next, our next column is the frequency. Remember, it's a frequency distribution table. So the frequency. Now in this, we're just now counting how many times that value has been noted. So for 0, the value is 4. For 1, the value is, as you can see, 5 and another 1, which makes it 6. For 2, we have 5. For 3, we have 3. And for 4, we have 2. Okay? So if we were to do the summation of how many households we looked at, ideally, we just add this to get the total number of households that data was taken from. So it is clear that we have, this makes 10, 15, 20. If we look at our data set, if we are able to count, then you will see we have 20 households that data was taken from. Next, okay, we want to be able to have a grouped frequency distribution. Now this one is categorical because we only had categories. What happens when we have a very large sample size? It's easier to make a grouped frequency distribution. And the steps are quite easy. First of all, we find the range. Now, in this case, what does range mean? Range means that you need to identify the smallest value and the largest value in that data set. Once you identify them, then you subtract. Of course, the smallest you subtract from the largest. Then find the class width by dividing the range which you have already calculated by the number of classes and rounding up. Rounding up means if you get 2.4, then it means round up to 3. That is, you round up to the next whole number. Then pick a suitable starting point that is less than or equal to the minimum value. So what we need to note is that the rule of thumb, the classes cannot be less than 5. You can do from 5 and beyond. Our example now. So we move to our example on how to come up with the grouped frequency distribution. Now, or rather group frequency table. We have an example here. Alex measured the length of leaves on the oak tree to the nearest centimeter. Of course, we have our data set there. Then we are told to construct a grouped frequency distribution table. The first step was to calculate the range. Now the range requires that we identify which is our smallest value. If I look through my data, it seems that my smallest value is actually 1. If I look through my data, what is my largest value? From investigation, my largest value is 18. You can feel free to actually have the data ordered just so that you don't make a mistake of not identifying the correct values. So we start with calculating the range. We have seen that the highest value in our case is 18, the smallest is 1. So when we subtract, what do we get? We get 17. Good. The next step requires that we find the class width. Okay? The class width is actually the class interval. So throughout, we need to maintain that class interval. And how do we do this? By dividing the range by the number of classes. Now, this number of classes, as long as we know that they are supposed to be over 5, then you can pick any number that you're interested in. In our case, let's just pick the 5 and see what happens. So the class width, okay, the class width in this case becomes 17 divided by our class groups, divide by 5. So remember what what I told you in the first, as we were beginning the class, that have your notebook, have your pen, and don't forget to have your calculator. So let's proceed. If we divide 17 by 5, what do we get? So I have my calculator, which I'll use in order to make things easier for us. So 17 divided by 5 gives us 3.4. Now, remember what we said, that once you get the solution, you round up. If 3.4 is the class width, then we take the next whole number, which becomes what? Correct, 4. Okay? Now, that said, we are told to pick a suitable starting point less than or equal to the minimum value. Remember our minimum value? Yes, 1. It was our minimum value. So we can choose to work with 1, or we can pick a value that is less than 1. In our case, how about we start with 0? and see how this goes. So for the classes, I'll just write classes so that we are able to understand what you're going through. Now, since I've decided my starting point is 0, it means 0 becomes the lower limit of my first class. The next lower limit would be plus the width that we have gotten, which is 4. The next lower limit for the next class would be 4 added to 4, which is 8, followed by 4 added to 8, which is 12, followed by 4 added to 12, which is 16. Now, if you count up, how many groups do we have? 1, 2, 3, 4, and 5. So now we have all the lower limits of our classes. Here comes how to get the upper limit for the classes. Now remember, the width throughout should be 4. So what value gets us to the 4th value that becomes our upper class? Let's do this simply so that you can understand. If I am including from 0, then 0 becomes my first value. The second value becomes 1. Third becomes 2. The fourth becomes 3. So automatically, 0 to 3 accommodates the width 4. Okay? So throughout, we want to make sure we have maintained our width as 4. Now, a clever way of doing it is already we have all the lower limits in our classes. So it will just be a value under the lower limit. So if our next class is 8, then it means the limit here is 7. Our next class is 12, then it means the limit here is 11. Good. Our next class has the lower limit 16, then it means we have 15. Good. Then the last one, how do you go about it? Okay, I know most of you are going by the example that you have just seen, that you can actually count up to know the last one, 16, 17, 18, and 19. So 19 becomes the last class. Now, if you realize, the last group here has 16, the last class here has 16 to 19. Remember, our highest value was what? 18. Okay? So it means it's accommodated. Now, we move on to the next column. Now, as previously done with the categorical data set, we still follow the same. The next column requires that we tally. What we have here are class limits, meaning that it's a closed set. All values are included. So wherever the value in our data lies, we have to tally it until we have made sure that all values have been accommodated. So let's go back to our data. Okay, there is our data. The first value we have is 9. Where does 9 lie? In the class 8 to 11. So we tally that. Then we have 16. 16 lies in the class 16 to 19. Then we have 13. Okay. Then we have 7. Okay. 7 is here. The next one is 8. 8 is there. The next one is 4. Where does 4 lie? Here. The next one is 18. Where does 18 lie? In the last class. Next one is 10. Okay, 10 lies here. Next one is 17. Where does 17 lie? There. Next one is 18. Okay. The next one is 9. 9 lies in the class 8 to 11. The next one is 12. Our 12 is here. Okay. After 12, we have 5. 5 lies here. After 5, we have 9. Okay. Now, where 9 lies, we already have tallied 4, so we close that group to mark the 5th one. Then we have a second 9, so 9 there, 16. Okay. In this class, we already have 4, so we close that one with the 5th one. Then we have 1, so our first class gets its first tally. We have 8. Okay. Then we have 17. Good. I hope you are finding this fun as we do it together. Then we have 1. Okay. We have 10. 10 lies in the class 8 to 11. Okay. Then we have 5. Good. Then we have 9. Okay. So there's a class that is moving up very fast. Then we have 11. Okay. Same class. So we close that. We have 15. Okay. We have 6. Good. So 6 lies in the class 4 to 7. So we close that. Then we have 14. Good. Then we have 9 again. Wow. 1. We can already see which class is very active. Then we have 12. Okay. Then we have 5. Next is 16. Okay. After 16, we have 4. After 4, 16 again. Then 8. Okay. 15. Good. 14. 14 still lies in that class. And last but not least, 17. And we are done with our tally. Good job, everyone, for following. Now, next, the same way we handled our categorical, we must now count the tally and write it as a value for our frequency. Okay? Quite easy. The first class, 0 to 3, has 3 values. So this is 3. We have 7. 8 to 11 has 12. 12 to 15 has 7. Then 16 to 19 has how many, if you can see? Yes, correct. There are 9. So we have come up with our classes. We have been able to tally all the data that is represented, that Alex had measured the leaves, then gotten the frequency. Now, we have something that we need to discuss below there, what we call limits and boundaries. This is very key because it will apply in our next session where we are introducing numerical measurements. Now, if we look at the classes that we have here right now, they are what we call class limits. The unique identifier for class limits is that the upper limit of the first class will be a different value from the lower limit of the next class. There are 2 different values. That is what we refer to as class limits. But we also have class boundaries, which are critical when doing some calculations in terms of computation for the median and also the mode for grouped data. So how do we get class boundaries from class limits? Now, we'll do this together. Remember our classes? Our classes, which are class limits, was 0 to 3. Okay. 4 to, can you remember? 7, good. 8 to 11, good. 12 to, can you remember? 15. And last but not least, 16 to 19. So these classes were class limits. Let me put limits in brackets there. Now we want to come up with class boundaries because they are very critical when it comes to our computation in the next session. So for class boundaries, it's actually very simple. How do you go about it? Now to get the boundaries of the first class, first we calculate the upper boundary. How do we get the upper boundary? The upper boundary will be the upper limit of the first class plus the lower limit of the next class divided by 2. Okay? So what does that give us? 3 plus 4, which gives us 7. Good. If we divide by 2, what do we get? 3.5. Correct. So let's start with that, 3.5. Now with boundaries, the beauty is the next class, I don't need to think about the lower limit. It's still the same value, okay? So this is 3.5. So now we calculate the second class upper boundary. So we have 7 and 8, which we add together and divide by 2. What does it give us? Oh yes, 7.5. Okay? So as before, 7.5 now becomes the upper class boundary for the second class, as well as the lower class boundary of the third class. So we have 7.5. So as you continue like that, you'll realize there's a system going on here. So next we get 11.5, which closes that class and opens the next one. Then we have 15.5, which closes and opens the next class. Okay? So how do we get the value of the last class boundary as well as the first class boundary? Something I want you to notice is that if you subtract the values throughout, you will realize the interval just by subtraction is actually 4. Okay? Unlike what we have seen with class limits, whereby if we subtract, then it will give us a false solution, which is 3. In the sense, class limits have a closed set. Remember that. So our getting the last class boundary and the first class boundary is very simple. Throughout, the class width is maintained. So ideally, the class width for the last class is 4. The class width for the first class is 4. So to get the last class boundary, we only need to add 4 to 15.5. And what does that give us? Yes, you got it. 19.5. Of course, now the same applies to the first class. To get the lower class boundary means that we subtract 4 from 3.5. If we subtract 4 from 3.5, what do we get? Kindly confirm so that we don't get a wrong value. You're correct. It actually takes us to negative 0.5. Now what we have done here is constructed class boundaries from class limits. Please take note because it will be very essential when it comes to the next part that we are going to. So we continue. So clearly we have managed to construct our grouped frequency distribution table. So the next part is numerical summaries of data. Now these are very simple actually. As we had highlighted before in our summary outline, is that for the numerical summaries of data, we would look at several, starting with the measures of location, measures of dispersion, measures of relationships, and measures of shapes. Now for measures of location, it's actually measures of central tendency, okay? I know that you are aware of the obvious ones that we keep using, that is the mean, median, and mode. But in our lesson today, we'll add two more, that is the geometric mean and the harmonic mean. We'll see how they go. So we start with the first one, that is the arithmetic mean. Of course, we don't refer to it every time as arithmetic mean. Most of us prefer using average or mean. Now, it's quite simple on how to go about calculating the arithmetic mean. If you have a data set, a raw data set, then all it means, it requires is that you add all observations, okay? Once you add them, that value you divide by the number of observation. If you look through our formula, it simply states mean is summation of x bar divided by summation of x, divided by n, where our x is values of observation, our sigma is summation, and n refers to the number of observation. So that we can follow through, we are saying that mean, which in a representation form is x bar, is equal to summation of our x's, all observations, divided by n. Let's look at an example. We are told to calculate the mean. We have a data set there of 60, 80, 90, and 120. How do we proceed from there? Now, for our solution, I want us to be very systematic in calculating. Once you get a question, the first thing that you need to show the examiner that you've understood what is being asked, write the formula, because it's going to guide you throughout. Now we have the mean being summation of all our x's divided by the number of observation. Now in our case here, our observations are what? We have 60, we have 80, we have 90, and 120. How many are they? Good, 4. They are actually 4. And what does 4 represent? Number of observations. So we'll have the summation, which requires that we add 60 with what? Yes, 80 with what? 90. And last but not least, 120 divided by the number of observations, which in our case are, we have 4. So 4. So what does that give us? Now remember, you're supposed to be having your calculator. So we do this together. If we add 60 to 80 to 90 to 120, it gives us 350. If we divide by 4, then we get 87.5. We don't know the story about this data, but for sure we can find out something, which is our mean, which is, after calculation, 87.5. Good. Something I need you to note is that the mean is actually very useful because it represents the values of most observations in the population. And any data set that you come across, among the values that will make sense in terms of that data set is the mean. So we've seen how to calculate the mean. When we have raw data, this is just raw data. What happens when that data is grouped? How do we go about getting the mean? Now, something we need to note is that the formula changes a bit. We have mean now becomes the summation of the product of x and f divided by the summation of f. Our x represents class mid points, Of course, we'll see how to get them. And our F represents the frequency. With that in mind, let's look at our example, which is example 2 for the arithmetic mean. We are told to find the mean for the following data that was obtained from students who are registered in a certain college. The table shows the age distribution. Let's see our table. So there we go. We have age in years and number of students, which is our frequency. Now, something I need us to note, look at our classes. Look at our classes throughout. What do you notice? Are they class limits or class boundaries? Oh yes, you got it. Class limits. So, now let's go to the calculation. Now this, we do it together. We have our age in years. Okay, our age in years. And the classes start from 15 to 19, all the way to 40 to 45. So we have 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, which is our last class. Now, the frequencies, that is the number of students. For the first class, how many students do we have? 21. Okay. The second class, we have 35 students whose age is between 20 and 24. Third class is 38. Fourth class, 49. Okay. Fifth class is 31. Good. And last but not least, our last class, which is 40 to 44, we have 19 students. Okay. Now, remember that in order to calculate our mean in grouped data, we must get X, because we need to find the product of X and F. And our X, we are defining as class midpoints. How do we get class midpoints? It's quite simple. For each class, you have two limits, the lower limit and the upper limit. Add the two limits and divide by 2. So our value of X here, if we add 15 and 19, what does that give us? 34. If we divide by 2, we get 17. Okay? So the first class limit for the first class is 17. Now, I want to give you an easy way of going about it. What is our class interval throughout? We have already said that we have, these are class limits that we have, meaning it's a closed set. So every value has to be accounted for. That means we have 15, 16, 17, 18, and 19 for the interval of 5. So throughout, we have 5. Now, this trick makes everything easy. Once we have calculated the first class midpoint, all we need to do is to add the interval throughout. So 17 added to 5, we get what? Good, 22. If we add 5 to 22, what do we get? Yes, 27. Add 5, what do we get? Good, 32. The next one becomes 37 and 42. And we have our values of X. Remember from the formula, we need the product of X and F. The product means we multiply the values of our frequency and our class midpoints. So if we start our calculation, 21 multiplied by 17 results to 357, okay? 35 multiplied by 22, we get 770, good. 38 multiplied by 27, we get 1026. 49 multiplied by 32, what do we get? Good, 1568. Then we have 31 multiplied by 37. That gives us what? 1147, that is 1147. Then 19 multiplied by 42 gives us what? Yes, 798 or 798. Now, what does the formula require? If you can remember, it requires that we get the total sum, okay? So we are going to add up the values of f, which is our denominator. So if we add up f, we are getting the summation of f. And also, we add up the values of our product of x and f. So we have summation x and f. Good. So what do we get? So if we, for the first one, we have 21 added to 35, added to 38, added to 49, added to 31, added to 19. I hope you're doing this with me so that you can confirm. Oh, good. We have 193. Okay? That means the students that we looked at, all of them in counting are 193. Now we come to the product of our class midpoint and f. That is the frequency. So we have 357 added to 770, added to 1026, added to 1568, added to 1147, added to 798. What does that give us? 5,666. Kindly confirm. So now we can proceed. We can proceed. We have summation of f as 193, summation of the product of x and f as 5,666. So our mean for grouped data, now our solution, remember the table is part of the solution. So x bar, which is the mean, is the summation of the product of x and f over or divided by the summation of the frequency. In our case, all you need to do now is substitute the values that we have already gotten. So the first, for the numerator, we have 5,666. The denominator, we have 193, which when we calculate, so if we divide by our numerator by 193, we get 29.3. I'll round it off to do 2 decimal places. 29.36. So what does this represent? That data that we had, one we know is from students who were registered in a certain college. What can we say about these students? We can say that the mean age of the registered students, okay, of the students, okay, those that were registered is 29.36 years. So that marks a key part of knowing about your data. So we've handled the mean in 2 ways, when you have raw data and when you have grouped data. So what is next? Next, we want to look at another form of measures of location or measures of central tendency, which is the mode. Now, the mode is very simple. It simply tells us the value within a frequency distribution that appears the most. Okay? So in that case, if you have raw data, the first thing you need to do is arrange it. Arrange it either in ascending or descending order, then identify which value appears the most. Automatically that becomes your mode. Now, let's imagine a data set to be able to understand that I have 2, 10, 3, 6, 2, 5, 7, 2. Now my data set, we are saying that the first thing, in order to find the mode, is to do what? Arrange the data. So if we arrange the data, we can see the least value is 2, so we have 2 represented. The next one, 2 again, 2 again, 3. After 3, we have the next value is 5, then 6, 7, then 10. Now the thing is, from your data set, make sure that after arranging, you have the same values, okay? That is, your number of observations should be equivalent. In our case, during the example, how many did you have? We had 1, 2, 3, 4, 5, 6, 7, 8. Once we arrange the data, we need to make sure that we have maintained the 8 number of observations. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8. Good. Now, if we look through our data, which number appears the most? Correct. 2. That means for this data set, the mode is equal to 2. Okay? Which is quite easily done. Now, what happens in a case where we have grouped data? There's something that you need to notice here, that sometimes a single value may not exist as such. In this case, we refer to the class with the highest frequency. So that means you end up now grouping your data in order to be able to identify the mode. Such a class which has the highest frequency is what we refer to as model class, okay? The class containing the mode. Of course, we know that the mode is a very important value. If you're a shopkeeper, let's say you're in one of the Bata franchises, if you notice, footwear for ladies, the stock that goes very fast is actually number 5, because most ladies have their shoes in terms of the size they wear as number 5. That means in case they're ordering, whatever brand of shoe, whatever style that comes in the market, they have to consider to make sure that the number that moves very fast is the one that they get in large quantities. Now, we want to now look at grouped data, how to find the mode for grouped data, and this we are going to do using a computational formula. A very easy one, whereby we're saying that mode is equal to L. We'll describe each parameter in order to understand what it means. Plus, in brackets we have the numerator F1 minus F0 divided by the denominator is 2F1 minus F0 minus F2, all that in bracket, multiplied by C. What do these parameters refer to? L refers to the lower class boundary. Remember what we said? That when it comes to the mode and the median, we'll use class boundaries. So if your example had class limits, at that particular point you need to now start changing to class boundaries. So we have L standing for lower class boundary of the class containing the mode. And the class containing the mode, as mentioned, is the one with the highest frequency. F0 is the frequency of the class before the model class. F1 is the frequency of the model class itself. F2 is the frequency of the class after the model class, and our C stands for the class interval. Now we are told to use example 2 for the arithmetic mean to compute the mode. We continue learning about this data set in terms of, first we have established the mean, now we want to establish the mode of this data set. If we can go back to our data set, let's go back so that we take it. So we had age in years, and our classes were from the first class 15 to 19 up to the last one 42, 44. So 15 to 19, 20 to 24, 25 to 29, good. 32, 34, good. 35 to 39, 42, 44, correct. Then we had the frequency, that is the number of students, 21 for the first class, so we had 21, 35, then 38, 49, okay, 38, 49, 31, and 19. 31 and 19. As mentioned, our formula requires that we get class boundaries. Now we already know that our data has class limits. So simply, let's create our boundaries. So, do you remember how to calculate the boundaries? We talked about this when we were developing our frequency table. Yes, we add the upper limit of the first class to the next lower limit, then divide the values by 2. Good. So if we add 19 and 20, that gives us 39. If we divide by 2, gives us 19.5, correct. So we have 19.5, which closes and opens the next class, 19.5. Good. The next one will be, once calculated, 24.5, which closes that class, opens the next class, 24.5. Good. The upper boundary here will be 29.5, which becomes the lower boundary in the next class, 29.5. Okay, yes, 34.5 is the upper boundary for that class, which now becomes the lower boundary of the next one, 34.5. Yes, 39.5 is the boundary of the upper boundary of this class, which closes that and opens the next class. Now remember, the values of the last class boundary and the values of the upper class boundary of the last class and the lower class boundary of the first class, we only need to add, or in this case, subtract the interval. As established before, the interval throughout is 5. Our class interval throughout is 5. So 39.5, if we add 5, gives us, yes, 44.5. If we subtract 5 from 19.5, what do we get? If we subtract 5, good, 14.5. Confirm, make sure that we have the same things. Now that said, we are good to go. Identify now, of the frequencies, which one is the highest frequency? 49, okay? And 49 lies in which class? Now we are going to refer to the class boundaries. So we have 29.5 to 34.5. Let me just show that, okay? So what does that mean? It means our model class, the class containing the mode, is what? 29.5 to 34.5. 0.5. Now with that done, it's very easy now to identify the values that we need. What does our formula tell us? We need to find the value of L, value of f of 1, f of f0, and f2, plus our c, which is our class interval that we already know that it's 5. Now in this case, so for our solution, let's see whether we can finish up a bit from here. Our mode, as per the computational formula, is L, plus in brackets we have f of 1 minus f0, good, 2 f of 1 minus f0 minus f of 2, which this bracket we multiply by the class interval. Now our L is the lower class boundary of the model class. We have the model class here, 29.5 to 34.5. So what is the lower boundary? 29.5. So our value of L is 29.5. The description of our parameters. What does F0 represent? So we can go to the description. F0 represents the frequency of the class before the model class. This is our model class, the one that has a frequency of 49. So the one before, its frequency is 38. So our F0 is 38. Good. Our F1 is described as the frequency of the model class. And the frequency of the model class is 49. Good. So F1 is 49. F2 is the frequency of the class after the model class. So after, whose frequency is 31. And we already know our value of C, which is the class interval throughout, is 5. We have the parameters that we need in order now to compute our mode. So let's do this together. Substitute all values. So we have mode will be, our L value is 29.5 plus in brackets we have F1, which is 49, minus our F2. Our F2 was 38. Sorry, our F note, not F2, our F note. So F1 minus F note, which is 38, divided by, okay, so let me put that in bracket. We have 2 multiplied by F1. So 2 times 49 minus F naught, which is 38, minus F2, and our F2 is 31. Then we close bracket, which we are multiplying by 5. So take your calculator. Let's see what value you're getting as the model age. So if we calculate this together, let's see what we get. Okay. So I'll start with, the easiest way to do this is to use BODMAS. That acronym that you learned a long time ago, brackets of multiplication, what else? Brackets of multiplication, division. I know you remember. So remind yourself of BODMAS so that you don't forget on how to handle the calculation. Brackets of division, multiplication, addition, and subtraction. So we start with the bracket. What is the value that we get for the bracket? Okay. So once we do that, so we have 49, which is our numerator, 49 minus 38, which gives us 11. So let's just do this together systematically. So we have 11. Then our denominator, we have, of course, we have 2 that is being multiplied by 49. Then we subtract 38 and 31, which gives us 29. Now that makes it easy for us to work with. So 11 divided by 29 gives us a value that we multiply by 5, then add to 29.5. This gives our mode, gives us the mode 31.39, okay? 31.39, I'm truncating in 2 decimal places. 31.39 years. Remember that. That's the model age. Now, something you need to note. 31.39 is actually a value that lies in the class that contains the highest frequency. So for sure, the value that we have calculated is a correct value. I hope you can follow up to there. Next, we want to look at, after the mode, we want to look at the median. Now, when you talk of the median, simple understanding, what does median mean? Of course, it refers to the middle value. Now, there are 2 ways to go about this. If you have raw data, we are looking at whether your data is odd or even. Odd means that it's not divisible by 2. Even means that it's divisible by 2. Now, whatever raw data you get, the thing to do is first arrange your data in either ascending or descending order. Whatever suits your fancy, pick that and run with it. Then, depending on whether it is odd or even data set, we have a way in which can help you to be able to get the exact value of the median. For example, we have a data set here. If we count our data set, we have values 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, 9 is odd, meaning it's not divisible by 2. So with an odd data set, the good thing is that there will be a unique identifier that becomes our median, which is the middle value. Now, to get the position of the median in that data set, after arranging, we just need to add the number of observations to 1, then divide by 2, and that value becomes, that n plus 1 divided by 2 value becomes our median. In our case, for this data set, our n plus 1 divided by 2, number of observations are 9 plus 1, which gives us 10. When we divide by 2, we have 5. So the 5th value in our data set is the median. Of course, we already have our data set arranged, so I'll pick it from the arranged data set. We have 8, 9, we have 13, 14, 14.5. Next we have 17, 18, 17, 18, 20, and 32. Okay? So which is the 5th value? We have 1, 2, 3, 4. The 5th value is 14.5. So while standing on the 5th value, the numbers before are, the observations before are actually equivalent to the observations after the median. Both of them are 4 and 4. So our median, so let's write here. So in this case, median will be 14.5. We don't know the story about this data set, but then again, 1, it's odd. So that means we have a unique value for the median, which after arranging, we have identified as 14.5. What happens when we have an even data set? Because we don't have an example here, we'll use the same data set, only add an extra value to see how it goes. So for even data set, we want to see, let me call this odd data set, so that we can be able to differentiate what we are doing. So for even, I'll pick the same but add an extra value here. So we have 8, 9, 13, 14, 14.5, 17, 18, 20, 32. Then we add another one, 33. Because we have already arranged, let me add 33. So now our data set is of 10 observations. How do we get the median when we have an even data set? All you need to do is identify the two values at the center, which in our case here are 14.5 and 17. Once we identify those values, we add them and divide by 2. So in this case, our median will be 14.5 plus 17 divided by 2. What do we get? Take your calculator. Let's check what you're getting. So 14.5 plus 17 divided by 2 gives us 15.75 as the median. Well done. So your data set, when it is raw, it can either be odd or even. Now what happens when we have grouped data set? What happens when we have grouped data set? The same way we had a computational formula for the mode, then there's also a computational formula for the median. Now our computational formula is as follows. We have the median being equal to L plus, in brackets we have n over 2 minus CFO or CF naught over F1 multiplied by C. Now we want to describe each of these parameters. What do they mean? L actually represents the lower class boundary of the class containing the median. N refers to the number of observations. CFO is the cumulative frequency of the class before that containing the median. F1 is the frequency of the class containing the median. Now remember that you're supposed to use boundaries. The same way we have used boundaries in getting the mode, we use boundaries in getting the median. But how do we identify the class containing the median? How do we identify the class containing the median? For that, we'll need now to come up with an extra column that gives our cumulative frequency. Cumulative frequency in our case here is what we are calling CF. And CF naught will refer to the cumulative frequency of the class before that containing the median. So we can go back to our data set. Our data set, because our example tells us now to continue finding out about example 2 of the arithmetic mean, what the median is. So we had age in years, okay, age in years. If you can remember correctly, we had 15 to 19 as the classes, 20 to 24, 25 to 29, 30 to 34, good, 35 to 39, and 40 to 44. Now these classes, we had already transformed them into boundaries, which we had gotten 14.5 to 19.5, 19.5 to 24.5, 24.5 to 29.5, 29.5 to 34.5, then 34.5 to 39.5, 39.5 to 44.5. So after that transformation, we can have now our frequency. If you can remember very well, let's just go back to the initial question so that we get the data set well. So we had 21, 35, good, 38, 49, good, 31, and 19. Okay, so we have our data set. So next, we get our cumulative frequency. If you look at the formula, it has a parameter CF naught, and we have already explained that CF naught refers to cumulative frequency of the class before that containing the median. So that means, let's come up with our frequency column, our cumulative frequency column. The first value of the cumulative frequency column is actually the first value of the frequency, which is 21 in our case. So the next value will be our 21 plus the next frequency, which is 35, giving us 56, plus 38, giving us 94, good, plus 49, giving us 143, plus 31, giving us 174, plus 19, giving us 193. If you remember very well, the summation of the frequency was 193. So we have cumulated the frequency up until the last value. Now, how do we identify what we are referring to as class containing the median? How do we identify the class containing the median? The parameter n over 2 will be of good use to us. N over 2 will enable us to be able to trace where our median class. N over 2 in this case is the same as 193 divided by 2, which is what value? So that gives us 96.5. Now, it's very easy on identifying the class. Let's go to the cumulative frequency. If we look at 96.5, is it contained in the first frequency, cumulative frequency of 21? Clearly not. It is not contained in 56. Also, it is not contained in 94, but it's actually accommodated in 143, because by the time you get to 143, you have accommodated from 95 up to 143. So that means we have identified our median class. We have identified our median class. From the formula, we are required to get the lower class boundary of the median class, and our lower class boundary, which is L, is 29.5. Next, we are required to get the CF naught. Our CF naught, the description is that it's the cumulative frequency of the class before that containing the median. So we have the class containing the median. Cumulative frequency before is 94. So CF naught is 94. Good. Let's just go back to the formula. Then F1 is the frequency of the class containing the median. So our F1 will be the frequency of the median class, which is 49. We have all the values of all the parameters that are involved in the computational formula. So all we need to do, substitute in the formula, then you'll be able to get your solution, or rather your median age in this case. Okay, so let's do this together. So remember, the table is part of the solution as you're calculating. So our median, as per the formula, you can see there, is L plus In brackets, we have n over 2 minus CF naught divided by F1 multiplied by our C. Okay, C, of course, is the class interval, and throughout the class interval for our example is 5. Now, if we substitute the values, what do we get? Our L was 29.5, good, plus, in brackets, we had already calculated n over 2, which we got what? Yes, 96.5. Our CF of 0, what did we get? Yes, it was 94. Then the frequency of that median class was what? 49. Then we multiply with our class interval, which is 5. So remember again, we go back to something that we were taught in elementary school. We have to use board mass so that we don't get confused. Let's just write it over here so that we keep reminding ourselves. So we work with the brackets first, okay, and move on to multiplication in this case, then addition. So we have 96.5 minus 94, which is divided by 49 as our bracket. Then we multiply that value with 5 and add 29.5, which gives us, so I'll truncate it to 2 decimal places, 29.75. Remember, our data is in years. So what do we have several things that we have found out about this group of students. We got the mean age, 31 point something. We got the mode, and we also got the median. So we have something to talk about when it comes to that data set. Our next topic of interest is geometric mean. What do we mean by geometric mean? Now, it's actually a measure of central tendency. That's why it's there. And it measures industrial growth rates. What do we mean by industrial growth rates? Let's take, for example, our telecommunication industries. The ones that come to mind, we have Safaricom, we have Airtel, we have Telcom. If we want to talk about how the telecommunication industry is doing, then we can look at the geometric mean, which will give us the industrial growth rate. Remember, each of those players in that industry has its own growth rate. But then again, how do we speak wholesomely about that industry? We are saying that geometric mean is defined as the nth root of the product of n observations. So our geometric mean is the, as you can see, nth root of the product of the observations. Now let's work out, let's look at an example to understand better. We're told in 2015, 5 firms registered the following economic growth rates. One had 26% growth rate, 32%, 41%, 18%, and 36%. Of course, the question is for us to find the geometric mean. How do we find the geometric mean? So we have already defined the geometric mean as the nth root of our product rates. So x1 multiplied by x2 multiplied by up to xn. In our example, our n is the number of observations, of course. How many observations do we have? 5. So we are looking at the 5th root, okay? The 5th root of the product of all growth rates. Now, since they are all in percentages, then we can just use the values. Whatever outcome we'll get will still be a percentage. So we have 26 multiplied by 32 multiplied by 41 multiplied by 18 multiplied by 36. So once you get the product, then you find the fifth root in order to get the geometric mean. Okay, so we can do this together. Get the product. So 26 multiplied by 32 multiplied by 41 multiplied by 18 multiplied by 36. Okay, let me just write the value. So we have 22 104,576, which now we are getting the fifth root. Okay, so you need to be very cautious on getting the fifth root. So if you're from your calculator, you should be able to easily find how to get the root in whatever value from the third, fourth, fifth, sixth, and so on, since the second is just the square root, which we are accustomed to. Once we get the fifth root, we are getting the value 29.44 in 2 decimal places. And remember, our values were in percentage, so the geometric mean for our data set is 29.44%. I hope we are following. So that means in this industry, the economic growth rate or the industrial growth rate is 29.44. We are almost done. Next, we want to look at the harmonic mean. Remember, for the numerical measures, we said we wanted to look at several things, 5 in particular: the arithmetic mean, the mode, the median, geometric mean, and harmonic mean. So this is our fifth one, that is the harmonic mean. Now, the harmonic mean, what is the definition? If you look at our definition, we are saying that this is a measure of central tendency which is used to determine the average growth rates for economies. Now, when we talk of economies, we are actually looking at different countries, how they are doing in terms of their, let me call it their GDP. So if we want to look at the growth rates of different economies, if we want to talk about the growth rates of different economies together, we look for the harmonic mean. Case in point, we can look at the East African region. We can compare it to other regions in our African continent. So how do we calculate the harmonic mean? We are told that it is defined as the reciprocal of the average of the reciprocals of all the values given. So if you look at this, we have 1 over, so automatically when it is a fraction, 1 over, it's a reciprocal. And if you notice, the additions in the brackets are also reciprocals multiplied by 1 over n, which is the number of observation, which is also a reciprocal. From other books or other sources, the formula might be defined as, instead of 1 here at the numerator, n. So n divided by now the addition of the reciprocals of the growth rates of those economies. It is actually correct because all you need to do is to work with 1 over n, be able to calculate a bit or play around with the formula in order to have n as your numerator. That said, we'll still proceed with what we have. We have an example. Our example says the economic growth rates of 5 countries were given as 20%, 15%, 25%, 10%, and 5%. We are told to calculate the harmonic mean. We have already seen that harmonic mean Okay, reciprocal of reciprocals. So our n is 5, so 1 over 5 divided by, multiplied by. So since all of them are percentages, then automatically we can just use the values as they are. Whatever solution we get will also be a percentage. So 1 over 20 plus 1 over 15 plus 1 over 25, I believe, plus 1 over 10 plus 1 over 5. Good. So we have all of them. So once we do that, what do we get as the harmonic mean? Now move with me. Make sure you have your calculator with you. So we have 1 over, I'll do the addition first because it's what is in bracket, 1 over 20 plus 1 over 15 plus 1 over 25 plus 1 over 10 plus 1 over 5, okay, which gives me 137 over 300, which now I multiply by 1 over 5, okay, giving me 137 over 1,500, which I now make it to be, so 1 over 137 divided by 1,500, which becomes what? So 1 divided by the answer. So you end up having the reciprocal of this, which is 1,500 over 137, which in 2 decimal places is 10.95%. So the harmonic mean in our example as calculated becomes 10.95, which brings us to the end of our lesson. Now I'll advise you to be keen on every step. Whatever concept you have not understood, go back and listen again. Make sure you have your pen, your notebook, and your calculator. Then redo the question until you get the concept. I wish you a good rest of the day as we embark on the next class next time. Bye-bye.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.